Every single day, we're all sending emails, streaming movies, hopping on video calls, and we don't even think about it. But behind that magic is this huge invisible world of technology. Today, we're going to peek behind the curtain at the hidden infrastructure that makes our digital lives possible. Let's follow the data and meet the people who build its world.
I mean, really, stop and think about that for a second. You click one button and boom, you're talking face-to-face with someone thousands of miles away in crystal clear HD. How on earth does that happen? How does a signal cross oceans in literally the blink of an eye?
Well, it's not magic. It's the result of some seriously meticulous design by a very specific kind of expert, the transport network architect. These are the folks who design the digital superhighways our data travels on. They are the invisible builders of our connected world.
To really get what these architects do, we're going to follow the evolution of the job through the career of one architect. We'll trace his journey over 2 decades, from the early days of the internet boom all the way to the dawn of 5G. So let's start at the beginning, when the internet was facing its first really big crisis.
Okay, so picture it. The mid-2000s. The internet is just exploding. Millions and millions of new people are logging on. And the old infrastructure, well, it was practically groaning under the pressure. The big question on every architect's mind was, how do you build a bigger, faster internet without the whole thing just grinding to a halt?
One of the key answers was this absolutely brilliant technology called DWDM. Yeah, I know, it's a mouthful. Dense wavelength division multiplexing. But the idea behind it is actually pretty beautiful. Imagine you've got one tiny fiber optic cable, which is like a highway. How do you get way more traffic on it?
The process is genius in its simplicity. First, your data, your video, your email, gets turned into a pulse of light. Then, each stream of data gets its own unique color. All these different colors then travel down the same single fiber, all at the same time, and at the other end they're perfectly separated. It literally turns a single-lane road into a multicolored superhighway for light. Just an incredible idea.
So, you've got your superhighway. That's great. But how do you make sure all the data knows exactly where to go and gets there as fast as humanly possible? That's where the second piece of the puzzle comes in, MPLS. So here's how it works. When a little packet of your data enters the network, MPLS just slaps a simple label on it. Think of it like a zip code. From that point on, the network doesn't have to read the whole long, complicated address. It just reads that short little label. This creates a pre-planned, super fast path for the data. It's like giving your data its own personal GPS route, so it takes the most efficient path, every single time.
And here's the real kicker. By combining these two technologies, architects could completely separate the thinking part of the network from the transport part. This made the whole system way more efficient. And for you and me, that meant a much more reliable internet, fewer annoying service outages, and it even lowered costs for the providers.
All right, so with that foundation in place, the next huge challenge was just sheer scale. The internet wasn't just for people at home anymore. Our architect saw his job shift from just building the highway to managing traffic across entire continents for massive industries.
And the scale was just immense. Over the next few years, our architect was leading more than 10 enormous, state-level projects. I mean, these weren't little upgrades. We're talking complete overhauls of a country's core internet infrastructure to make sure everything from banks to hospitals stayed online.
You can bet that this kind of expertise became incredibly valuable. He started acting as a high-level consultant, advising over 20 major telecom companies all across the Asia-Pacific region on how they could design and build out their networks for the future.
And this wasn't just tech for tech's sake. This work had a massive business impact. By pushing for modern solutions like bringing fiber optic cables directly to our homes, what's called FTTX or fiber to the X, he helped his partners grow their new business pipelines by an average of 15%. It just shows this role is as much about driving economic growth as it is about wires and code.
And that brings us right up to the modern era, where the challenge has changed all over again. You know, with 5G, the cloud, the Internet of Things, the network doesn't just need to be fast anymore, it has to be smart.
So today's problem? It's all about complexity. How do you seamlessly weave in brand new technologies like 5G? How do you possibly manage a network that is constantly changing with data flying in from billions of different devices? You're going to need a whole new kind of tool.
And that tool is software-defined networking, or SDN.
Now, if the fiber optic cables are the body of the network, the muscles and bones, then you can think of SDN as the brain. It's a layer of intelligent software that can control and manage all that physical hardware from one central place, making the entire network incredibly flexible and quick to respond. So the toolkit for today's architect is seriously sophisticated. They're juggling things like 5G integration and the crazy growth of cloud data centers. They're even using smarter routing techniques like segment routing, which is basically the next evolution of MPLS, to create even more flexible and efficient data paths. It is a whole new level of complex.
And this isn't some lone genius working in a dark room. Not at all. A modern network architect is also a leader, coordinating huge teams with people from all different departments. In this case, a team of 45 professionals, all working together to build these incredibly complex, future-proof networks.
And all of this brings us to the final evolution of the role. Over 2 decades, the transport network architect has transformed from a hands-on engineer who is just laying down the pipes to a high-level strategist who's advising the boardroom. I mean, just look at the shift. In the past, the job was all about managing physical hardware to give us that raw connectivity. Now, it's about managing intelligent software to hit big business goals, like boosting performance, and, maybe most importantly, lowering the total cost of owning and running that network for a company.
This quote really captures the mission perfectly. The goal for the modern architect is to use network technology as a tool to drive digital transformation, to help businesses completely change how they operate in this new digital world.
So, the next time you make a video call, just take a second to remember the invisible architects who designed the pathway for your data to travel. Their work has literally shaped our world. And it leaves us with one last thought. The incredibly fast network we use every day was once just a crazy idea on a blueprint. What mind-bending infrastructure are the architects of tomorrow designing for us right now?